Okay, so we have to write this in order. We need x cubed, x squared, x, and then constant always. Whether you're using synthetic division or long division, you can't leave anybody out, okay? It's kind of like if you guys are absent, I don't get rid of your desk. We keep it there so when you come back, there's a place for you to sit, right? So now as we divide, we're going to ask ourselves this outer piece here, the very first one, even if this were a trinomial, we just look at the first one. And I say, how many times does 2x go into 4x cubed? Well, 2 goes into 4 2 times. How many times does x cubed go into, does x go into x cubed? X squared. So we figure out how many times the first guy goes in. Then what is our verb? What are we going to do? Multiply, just like we did with our little numbers in 3rd grade. So now take 2x squared and multiply it, distribute it to both of these. So 2x squared times 2x is 4x cubed. And 2x squared times positive 3 is 6x squared. Now these two, right? These two right here, the very first term is always going to match. If it doesn't match, you goofed up and you got to do something else. Yeah, that you pick the wrong number. So let's make a note here that the yellow parts always match, right? What was our verb then? Once we wrote those down, what did you guys tell me to do? Subtract. Now you can see we're subtracting a binomial. It's very easy to forget a sign if you do that. So rather than subtract, we're going to add the opposite. That's the same thing, right? In math, adding the opposite. So add opposite. That means you're going to change the sign of everyone you see. So this is positive, it's now negative. This was positive, now it's negative. Now let's add them up. What's 4x cubed plus negative 4x cubed? 0, and that should always be 0. But on this one, what's negative 6x squared plus negative 6x squared? Negative 12x squared. If we would have left that a plus and you saw a minus and a plus together, what might your eyes do? Yeah, you would put 0. But remember, that was really negative x minus x, and it's 12. But you see a negative and a positive, your instinct is to say, oh, they're gone. So it's really better if you just change everyone's sign and add. You will not have that subtraction mistake. Okay, and then what did you tell me we do after we subtract or add the opposite in our case? We bring that guy down, right? Okay, now we just repeat and we do this until we're done. So now how many times does 2x go into negative 12x squared? Yeah, it's going to be minus, right? 6x. And you'll know if you accidentally pick the wrong number because it's not going to multiply correctly, right? So now what's negative 6x times 2x? Negative 12x squared. What's negative 6x times 3? Negative 18x, right? Now we're going to add the opposite. So I'm going to make this a plus, and I'm going to change the signs. This way I'm adding, and I won't have that problem of a mess up. So what's negative 12 plus 12? 0, and we want that. That should always be 0 with this division. What's 0 plus 18? 18. And then we got this little 6 we're going to bring him down. Okay, how many times, let me get another color. How many times does 2x go into 18x? Positive 9. Now we take this and multiply it by the side. 9 times 2, or 9 times 2x really, 18x. 9 times 3, right? And now we're going to change everybody's sign so we can add. Again, that first one is going to zero out. And what's 6 plus negative 27? Negative 21. Now, once you've run out of x's, you know that you're done. You can't add anymore, so this is left. So that's minus 21 over 2x plus 3. Now, this is kind of cool. It tells us a couple of things. It tells us right now that 2x plus 3 is not a factor of this. It doesn't go in evenly, right? Does anyone know what it does tell us? Do you remember when you learned this a long time ago? We'll see in a minute. I have to leave the suspense there so you just can't wait for the next problem. That's it, we're done. Not bad, right? It's easier than long division because we don't have to go out and be multiplying and looking. The arithmetic is easy. It's small numbers, right? So let's try this one. We're going to do it again. Are these in order? 3, 2, 1, and none. So we're okay. We don't have to put a 0 in, right? All right. Y'all want to take a second and try this one, or you want me to go through it with you? You want to try it? You want me to go? I'll go through it. Okay. How many times does, remember, we only look at the first guy to figure out how many times he goes in. So how many times does x go into 6x cubed? 6x squared, right? This is going to be down in power from that because we're dividing. So what's, now take 6x and multiply it by both of these. 6x squared times x. 6x cubed. 6x squared times negative 2. Then we're going to add the opposite. When you guys see both of these here, more than likely, if you don't add the opposite, you're going to get a sign wrong. So we're going to add, but we got to change everybody's sign, right? Okay, that's going to zero out. What's negative 19 and 12? All right. How many times does x go into negative 7x squared? Minus 7x, correct? And notice these are going to count down. Since we're dividing by x to the first, your top, you're going to continue to count down. So 7 times negative 7x squared, negative 7x times negative 2 plus 14x. But we don't want to subtract. What are we going to do? Add the opposite. So we've got to change everybody's sign. And when we change everybody's sign, this one's going to zero out. And what's 16 and negative 14? Bring down that 4. All right. How many times does x go into 2x? 2. And 2 times x? 2 times. And we're going to add the opposite. No remainder. If the remainder is 0, that means x minus 2 is a factor. Now, one of the reasons that we want to know this, right? If I asked you to factor this guy and grouping wouldn't work, now you know that this problem is x minus 2 times 6x squared minus 7x plus 2, right? We have essentially, this allows you to factor. So now if I was being really mean and cranky and I said, I want you to finish factoring that, if this won't factor, and it might not, I don't know, I didn't factor it, but since we took it from a cube to a quadratic, you can always solve a quadratic because you have the quadratic formula, right? So this can be a big benefit in helping you factor things that before you thought wouldn't factor. So, but when we get 0, we know it's a factor. All right, let's do this same problem with synthetic division and see what the difference is. I like to compare them. So synthetic division, when should you try to use synthetic division? How do you know which way to use? If this is a binomial and it's just x plus something or x minus something, synthetic division's great. If it's got a number in front of it, then you would have to use fractions the whole way, and I know how y'all feel about that. And then if it's a trinomial, we have to do long division. Synthetic division only works when you're dividing by a binomial. It's best when there's a 1 there. But how we do it is if we took x minus 2 and set it equal to 0, what would x be? 2, correct? So we are dividing, we are putting a 2 out here. That's where that 2 comes from. Whatever this factor is, we could have used it on this, but you would have had -3/2 out there, and you would have had to multiply and divide and add with fractions. So sometimes people would rather do the long division. Okay, now what's going to go on the inside? Just your coefficients. So 6, -19, 16, -4. Any question as to where these numbers came from? That's easy, right? So for synthetic division, you carry down your first number. You just write it down. If you want to put a 0 there, you can put a 0 where my arrow is, if you want to. And all we do this time, our instructions, let's write those in another color. We multiply, then add. We don't have to change signs. We multiply and add. So what is 2 times 6? 12. You put 12 here. Now add down. -7. 2 times -7. -14. Add. That's 2. 2 times 2. And that's 0. Again, it is a factor. That 0 is very important for you to recognize what it does for you. Now, this was x cubed, right? The 6, -19, 16, and 4 came from x cubed. So what we do now to write it is we reduce this by 1 because we divided by an x. So this is 6x squared minus 7x plus 2. This was an x cubed right there in the original problem. So we go down 1 power because we divided by x, right? Did we get the same answer here and here? We did. Most of us would rather do synthetic. If I have a small binomial and that's what I'm dividing by, I would never pick long division. But if I have a number here which would cause me to divide by a fraction, or if it's bigger, a trinomial, then I use a long division. So what do we do with this? What is going to go on the outside? Let's practice one more. What goes on the outside? 1 or -1? -1. Because remember, we're not dividing by this number. We have to divide by a 0. Remember that. And then what's going to go across here? First, check to see if we have everyone. Does it go in order? 5, 4, uh-oh. There's no 3. There's no cube, is there? So what will we put for that cube? 0. So 1, -2, 0, 3, -2, 5. I'm going to make myself a note because I'm a kid and I might have to look at this again. Don't forget. I'm just going to put missing power. That will trigger your memory to remember there was no cube over here. If you forget the 0, there's nothing that can go right after that. There's no way to get the right answer. Okay, let's try this. We bring down that 1 and now multiply. Negative 1 times 1, negative 1, negative 1 and 2. What's negative 1 plus 2? Negative 1 times negative 3. 3. 3 plus 0. Negative 1 times 3. 0. Negative 1 times 0 is 0. 0 plus negative 2 is negative 2. Negative 1 times negative 2 is 2. And I get a 7. What does that tell me? Not means not a factor. Now, I want y'all to look at something. There might be more to it than that. So let's go type this thing into your calculator real quick. I know I'm going to mess that up because I always forget to scoot it over. You do not have to put a 0 in your calculator. Okay. Wait. Hold on, I accidentally hit something. Okay, so did everyone get that typed in? Now, see how there's a negative 1 out here? I want you to go to your table and look at negative 1. What's the answer? 7. What did you get? 7. So, whoa. So if you had, now y'all have never ever thought to do this before, but now you might think to do this. You know how sometimes I could say find f of negative 1 and you have to go plug it in? Well, this is to the 5th power. That's kind of big. And if this was something other than negative 1, like 3, and you had to do 3 to the 5th minus 2x, that could get big, right? So you can use synthetic division instead of plugging it into all of these different spots. And if you get a number here, that is the answer. That's what you would have got if you would have plugged it in here and figured it out. That tells you that negative 1, 7 is a point on that graph. So if I gave you this big, ugly, messy graph and you knew a 0, you could use synthetic division to find other points. Isn't that kind of cool? Admit it, this is a good time. This is what fun looks like, people. Hey, it's better than last Wednesday. Think where you were last Wednesday. No electricity, no water. Now we have no air. Okay, so how can we use this to help us factor? So if I gave you a problem and I wanted you to factor it and it was cubed and you couldn't group it, can you use synthetic division to get you to factor something quickly? You can, if somebody gives you some of the factors. If they don't give you any factors, you're kind of back at square one. But let's look at how we would do this. So if I know x plus 2 and x minus 3 are factors and I need to find the other one, I just divide them each. But let's be careful. There's one step where people get goofed up and then they're like, wait, I'm not getting anywhere. So all we have to do is let's just take the first one. And what would make this 0? Negative 2, correct? So we'll put a negative 2 and we'll do synthetic division. And this is, are they in order? 3, 2, 1, none. Yes. 2, negative 3, negative 11, and 6. So do this real quick. Y'all try it. Come on. You do it while I do it. See if you got it. Y'all try it. See if you got what I got. Now, I got a 0 here. So does that tell me I did it correct or incorrectly? Correct, because they told me it was a factor, and if something's a factor, you have to get a 0. So now what we're going to do is divide by the 3. But here's where people get goofed up. They go back and pick those same numbers and divide by 3. We don't want to do that. We have taken it from a cube to a square. So when we divide our second one, we want to use these numbers. This is where people get messed up. Right? So let's highlight and make sure that you pull your I here. If you divide it into the original, it's not going to be wrong, but it's not going to get you any further because you're just going to end up with the same numbers. So now, everybody get what I got? This is easy. We like synthetic division, right? So this original one was cubed, correct? This was cubed. So when I get this one, this yellow one, what power is the yellow one to? This one is squared because we've reduced it. Sometimes you'll see it as a reduced or depressed polynomial. So if this was cubed and we divided and got a square, we divided again. What power is this? Just 1, right? We go down a power. So this is 2x minus 1. So if you wanted to write this equation, right, it's x plus 2 times x minus 3 times 2x minus 1. That's what this stands for. You always look cubed, then squared, then 1. We will always go down a power each time. So what do you think's easier, factoring this by hand or using synthetic division? Now, once we got to right here, you could just factor that with your eyes. You don't have to do synthetic division again. But I think synthetic division is actually a little faster, isn't it? It's pretty easy. Okay. So I'm going to give you all a second, and I want you to take a test. Here's your test. You're going to try this one. It says f of 4. So what does that mean? I'm going to put a 4 out here, and I'm going to use synthetic division. So y'all try that one real quick. Okay, I'll run through it. So cubed, oh, there's no squared, so what do we need? That, if anything's going to make you miss it, it's going to be the 0. So bring down a 1. 4 times 1 is 4. 4 plus 0 is 4. 16, 18. What's 18 times 4? That's 20 times 4 minus 8, right? What is that? 72. So this is my answer. F of 4 equals 70. Wait, 77, not 75. Okay, so now let's do it the way you would have done it at the beginning of class. If I would have asked you to do this, you would say what? Remember, I really want you to set your math problems up this way. Open parentheses and then plug your number in. I'm going to need you to be good at that for calculus next year. Right? If you could do that when I ask you to plug x plus delta x in, it won't freak you out. Okay. What is 4 cubed? Right? What's 64 plus 8? There we go. It works. So if you're ever stuck, right? Synthetic division works. Actually, I think this is easier than having to put numbers in along here and cube them and square them and all that. This is pretty low key, right? So remember this. We often forget it and we go back to our old ways, but this is actually, usually with the synthetic division, if you don't have a calculator, your numbers are smaller. And I know this year you get a calculator for everything. But remember, when we get COVID under control, we'll go back to no notes, no calculators. That's going to come back in your future. And some of you guys are seniors, so you got that next year. Okay. Factor theorem. If f of 3 equals 0, then you know it's a factor. You know that x plus 3 is a factor of the polynomial. Let's think about that. If they tell me, let's pick another number so we have another one. If I say if f of 12 equals 0, right? Then x plus 12 is a factor, right? Actually, that should say x minus 12, not x plus 12. And that's a goof up in here. That should be a minus, right? Okay. If I give you zeros, this is kind of reviewing yesterday. If I give you zeros, what are the factors? Can you write the equation from the zeros? This is taking us back to yesterday, a little review. If negative 7 is a 0, what's the factor? X what? Plus 7. Times, if 3 is a 0, what's the factor? And if negative 4 is a factor, there we go. What are the x-intercepts for these factors? Negative 7, 0, 3, 0, negative 4, 0. And remember, I'm really picky. It really bothers me when it says intercept and you don't have to write the 0. Keep in mind, some of the math software doesn't make you write a 0. It makes me cringe. It might be a new trend, I don't know. Find a polynomial equation for a polynomial with the given zeros and multiplicity. So again, f of x equals, if I have a 0 at 0, what's the factor? Where does that come from? Just a plain x, right? It's not added or subtracted. Okay. Negative 2, what's that factor? X plus 2. A multiplicity of 2, what does that tell me to do? 2. And a 3 is what factor? Minus 3, right? Multiplicity of 3. Why did they do that? I don't like my numbers to match up. So I'm going to do multiplicity of 2 and highlight the 2. Since there's 2 2's there, I want you to know which 2 came from where. Multiplicity of 3 is how we got that 3. Now, actually, I'm going to take a step further. We're going to graph that in a second, just a quick graph. What are the x-intercepts? 0, 0, right? Negative 2, 0, and 3, 0. You could tell I'm really trying to work on that vocabulary of zeros. Now, what would the equation, or what would it look like? I have a 0 at 0, have one at negative 2, I have one at 3. I'm just going to assume it's going up. It didn't tell me it was positive or negative. We're just going to make it positive. So I know the right side goes up. What do I do when I get to the 3? Do I cross or do I bounce? It's cubed, which is an odd number, so we cross. And I have to get to the 0. 0 is raised to the first, which is odd, so we cross. Now, what about the 2? The 2 is even, and what does even tell us? We turn around. So we can get a nice, easy graph. Now, I don't know how tall any of those hills are, but I don't care how tall they are. I can at least get a graph. Now, let's check this out. This is cubed. This is squared. So now I'm to the 5th power. and one more makes 6. This is x to the 6th. So it's even. Both ends should go the same way. Are both ends going the same way? Yes. So I like this, right? Okay. Any questions about our division or about what we've done?